before we can get to some of the more complex of the derivations of g, we need to be able to do a problem that's pretty straightforward. But we'll have a couple of things that you may not have seen. This, by the way, again, works exactly the same with Q's and electric fields. Let's say that this distance from here to here, this is some point P, and this is a distance of x, and both of these distances are a from the bisector. We have defined gravitational field. Its direction, it's a vector, and its direction is the direction of a small mass would move. If I put a very, very small mass there, it would move this direction due to this one. So it would feel a gravitational force, a gravitational pull that way, and it would feel a gravitational pull that way. As we notice, the x components cancel. Sorry, the y components cancel, and the x components add. So what we get is that, again, if this is g and this is g, then there would be a gx and a gx. So we see that our g net would equal 2gx. Are we all in agreement with that? What I'm trying to do is I'm trying to work from large structures to detailed structures, because clarity of writing is clarity of thought. So now, let's figure out, we know what g is, because g equals big G, big M over r squared, where those would be the m's. And what about this gx? Well, I'm pretty sure we're going to need an angle here, aren't we? So let's define this one as theta. By the way, if you were thinking, oh no, what if I called that one theta? It actually wouldn't matter, because the sine of one angle equals the cosine of the other angle. You should know that the cosine of 60 degrees equals the sine of 30 degrees. If you pick the wrong angle, your answer will come out the same. It will look different until that sine or cosine disappears. Well, shoot, we do not, darn it. We do not have an angle.
You're right.
So we're going to define it. We know that gx equals g cosine of theta because it's adjacent. So now we have 2g cosine theta. And from this, we know that cosine of theta equals adjacent over hypotenuse. And the adjacent for our triangle would be x, and the hypotenuse would be r. We all good so far? So now this gives us g net equals 2g, there's g, big G, m over r squared. Cosine of theta is x over r, which equals 2gmx over r cubed. That doesn't look that difficult. Again, I really want people to see the organizational here. You big stuff, little stuff. This is where you're finding out, oh, so what does that equal? Put it over here. Don't do it all in the same spot, it gets messy. And if you can't read it, you don't get points for it on the test.
Right.
Well, this r, on the AP test it would say it didn't give you an r. We found that r ourselves. But from Pythagorean theorem, we can define r. Obviously, r squared equals a squared plus x squared, or r equals a squared plus x squared to the 1/2. Now, you may wonder, why did I go to the 1/2 and not put a square root? Because we're going to have cube here. And it's going to be much easier for us to cube the 1/2 than to cube the square root. So now, we put all of that together, and we get, can you see down here or not?
Yeah.
Okay, so we get G net equals 2 big G, m, and let me change that to little m, just so that we're consistent, x over a squared plus x squared to the 3/2. I'm going to put an arrow here to make it a vector, and we know it's pointing that direction, so I'm going to add negative I hat, because it's in the negative I hat, or the negative x direction.